Okay, cycle 2, week 4. We have 2 experiments this day. They are on page 7 of the Van Cleves book, and they are numbers 11 and 12. And number 11 is called On the Move, and the purpose is to kind of talk about why planets kind of stay in their orbits. The instructions call for cake pans. We're going to use these little plastic plates. And again, this one, the kids are going to do in pairs. So at the table, there will be enough little black plates for the kids to each have one for a pair of them. And then the instructions say to cut out the paper. I've already cut it out for you. So you'll just need to have the paper handy so that you can use it. Then it says to put the paper inside the tray. It just fits right down in there like that. And then you're going to have a marble, again, for each pair of students. So you can set the marble in the tray, and then you just kind of, hit it with your thumb. And I'm not holding it level. Let me see if I can do this. So now you can see it. Maybe. There we go. All right. So you just set it in the tray, and then you kind of flick it with your finger, and you watch how it goes around the circle. Then you take the paper out, and you do the exact same thing with the marble. And you notice how it moves a whole lot faster than it did with the paper in. So there's a couple of different applications here on this one. First is obviously the idea of inertia, and that the marble moves faster with no paper in it because there's nothing slowing it down. It just keeps rolling and rolling. And then the second thing is that objects that are in motion tend to remain in motion. And so the planets, as they're moving around, unless there's something that knocks them out of orbit or changes the gravitational pull that they have that's keeping them in orbit, they're going to keep going around and around in a circle. So some application questions that might be good to ask about this one. What types of balls might get a different result than a marble? What if I had like a wiffle ball or a cotton ball or a beach ball or a basketball? Those kinds of things. What if I had different kinds of paper? What kinds of paper would allow my ball to move more quickly, and what kinds of paper would impede that progress? Like what if I used sandpaper, or what if I used aluminum foil instead of cardstock? So those kinds of questions might be good. Again, you can take some extra time. Both of these experiments are really pretty quick. So it would be really great to slow down and just say, what do you observe? Feel the paper. What does it feel like? Feel the marble. What does it feel like? Feel the pan. What does it feel like? Those kinds of things. What is it that you're observing? Watch the marble as it goes around. What do you see? Is it rolling in the same direction? Does it change how it rolls based on if the paper is in there, or is it the same? All of those things are things that you can ask your kids to really help them just slow down and attend to what is it that I am looking at, and what are all the different things that might impact how this marble rolls around inside this little black plate. So that is the first one, On the Move. The Indescribable book has a devotion that goes with this one too. It's on page 160. And let me see if I can find it. Sorry, I should have had it marked. It's called The Pale Blue Dot. And this is kind of like talking about satellites as they orbit. This also might be a good one for week 1. As you know, we talk about the rope around the trees. We could talk about that. This is talking about what the Earth looks like from really, really far away and its orbit. So that might be a good one to use. The second experiment is number 12 on this page, and it is called Speedy. This says to do outside in an open area. Really, it's because they have given you 1 yard of string with a metal washer on the end, and you're going to be twirling it. So they obviously don't want you to be whacking each other in the head or in the eye, or launching the washer, across the room or whatever. So if the weather's nice and you can go outside, the plastic plate is great too. You can take it outside and, do it by the playground or in the shade of the, little drive-through or whatever. But you can also do it inside. I think we'll have plenty of room inside if you want to do it inside too. But the idea is that I'm going to push this back just a little bit so you guys can see. Okay, so you've got a washer. So the first class at each table is going to be the one to tie the washer. So the next two classes, it'll already be tied. But the idea is to watch how fast do I have to spin the washer to keep the string taut. And how many times in a second, maybe count, or how many times in 10 seconds or whatever, is my washer going around in order to keep basically its orbit, to keep my string taut. And then we're going to look at, what if my string is shorter? If my string is shorter, how many times is it going around to keep it taut? It goes around a whole lot faster, so it orbits many more times than if I have a really far away string. So the application here on this one is to kind of identify planets that have faster or slower orbiting speeds. And you can play around with this. How fast do I need to go to keep the string taut? How slow can I go to keep the string taut? What happens if I go really fast? What happens if I go really slowly? The application here in the book, it says, as the planet's distance from the sun increases, the gravity decreases. And so with less pull from the sun, the orbiting speed of the planet decreases. So Mercury, which is the closest to the sun, has the fastest orbiting speed, and Pluto, the furthest most, has the slowest. And don't email me about Pluto. I know it's not really a planet. So you can use Uranus if you want instead of Plato. That's totally fine. Or Neptune, whichever one happens to be further away at the time. Twirling the washer on the string. This is just a note that's in here. Twirling the washer on the string is not a true simulation of how planets move around the sun, because planets are not attached to the sun by a cord and do not move in a circular path. So you tutors that have the older kids, you're probably going to have some kid in your class that's going to be like, but that's not really how things orbit around the sun. You're right. This is just an illustration of the idea of gravity and the orbit and how things have to move quickly or more slowly based on the force that is applied to them. So those are the two for week 4. And I think that's it. In pairs for everybody. Orbiting planets. Oh, I have a note here. One of the kids, when I did cycle 2 last time, I was just asking them how might an astronaut use this information? And one of them said that they would use the information to make sure they tethered themselves to the space station or the spacecraft so they didn't fly off and get lost in space. So you can use that application as well if you would like to.